In two-dimensional space, we can represent a line using an equation like y equals mx plus b. In three-dimensional space, an equation like that doesn't work because it ends up describing a plane of space rather than a simple line. And so we need something else. So let's suppose I have a point out here, x naught, y naught, z naught, and I have a direction that my line is going to travel in. So let's imagine I have a vector on this line, and we'll call it the vector v. Okay, so we got a point on space, we got a vector pointing in the direction of the line or parallel to the line. So we're going to introduce, let's imagine that we have the origin down here somewhere. We're going to introduce a position vector, a vector from the origin out to this point, and we'll call it r naught. Then any point on the line can be represented as the sort of end of a vector r, where that vector r is the original r naught point plus some scaling of the vector v, right? Because this would be r naught plus 1v, this might be r naught plus 2v, 3v, 4v, right? We're combining this vector r naught with scalings of that vector v. And if we scale that vector v by t, then any vector r pointing to some point x, y, z on the line can be represented as r naught plus t times v. Now, in some cases, this vector form of a line is not horribly convenient, so we could break this down and say the vector v is the vector pointing to x, y, z, so it is the position vector x, y, z, right? This would be the vector from the origin out to x, y, z. The vector r naught here is x naught, y naught, z naught. And let's say the vector v has components v sub x, v sub y, and v sub z. Then here's a more written out vector form, and then we could scale this vector and combine the components here to say this is x naught plus t v sub x, y naught plus t v sub y, and z naught plus t v sub z. Now, because this vector is equal to this vector, the x component of a point on space can be represented using this expression, y and z the same. And so we can end up writing a set of parametric equations that are equivalent to this vector equation. We can say x of t is x naught plus t v sub x, y is equal to y naught plus t v sub y, and z is equal to z naught plus t v sub z. And this set of parametric equations is equivalent to this vector equation for a line. So we can write an equation of a line in 3 space using either of these two formats.